P-hacking, the tricks of bogus science. You've probably heard the term floating around, and let me tell you, it cuts right to the heart of a huge issue. How much can we really trust scientific research? Today, we're going to pull back that curtain and see what's really going on. All right, so let's get right into it. What is p-hacking, really? Well, at its core, it's when researchers play around with their data. They use all this flexibility they have to basically hunt for a result that looks important, a statistically significant one. In science, a low p-value is often treated like the holy grail. It's supposed to mean your finding isn't just a fluke. P-hacking is basically just torturing the data until it confesses, finding a low p-value even if the discovery isn't real at all. So, you might be wondering, how do they actually do it? Well, let's open up the P-Hackers Toolkit and take a peek inside. We're going to look at the common methods used to twist and distort scientific findings. And wow, there are a lot of tricks in the bag. Take HARKing, for instance. It sounds weird, but it just stands for hypothesizing after the results are known. That's when a researcher stumbles on a random correlation and then writes up their paper as if they geniusly predicted it all along. Or they might cherry-pick the data that looks good, or just stop collecting data the second the numbers look significant. It's all about forcing a result, not actually discovering one. This right here illustrates one of the sneakiest problems. It's sometimes called the garden of forking paths. Imagine a researcher making all these tiny little decisions while analyzing data. Which variable should I look at? What do I do with these weird outliers? Which statistical test should I run? If you try enough different combinations, you're almost guaranteed to find something that looks significant just by pure chance. Then the final paper presents that one lucky path as if it was the plan from day one. Now, this isn't just some nerdy academic debate. Not at all. The fallout from this kind of bogus research is incredibly real, and frankly, it can be pretty serious. The consequences are huge. They ripple out and end up affecting our health, the policies our governments make, and even our basic trust in science itself. And the damage is everywhere. In psychology, it caused the famous replication crisis, where scientists tried to repeat major foundational studies, and they just couldn't get the same result. In medicine, you could have useless drugs being sold as effective, all while harmful side effects get hidden away. Pharma companies can waste billions of dollars chasing findings that were never real to begin with. And we've all seen this in nutrition science, right? One day coffee is a superfood, the next it's going to kill you. It just creates total confusion for everyone. So here's the bottom line, the real societal damage. It completely erodes public trust in science. It wastes billions in funding. It can lead to genuinely harmful policies in medical advice. And maybe the worst part? It creates this culture where getting a flashy, exciting result is rewarded more than doing careful, honest, and sometimes boring work. But it's not all doom and gloom. The story doesn't end there. One of the best things about science is that it's designed to self-correct. So let's look at how the scientific community is actually fighting back to try and regain our trust. What's needed is a total culture shift, moving from this old, flawed way of doing things to a new, much more transparent way. So instead of making up a hypothesis after you see the results, you pre-register your entire study plan before you start. Instead of only publishing the significant findings, you publish everything, no matter the outcome. And instead of keeping your data and code secret, you share it so other people can check your work. And one of the most powerful tools in this fight is something called a registered report. This is brilliant. A scientist submits their research methods for review before they collect any data. A journal then decides to accept the study based on how good the question and the methods are. And if it's accepted, the journal promises to publish it no matter what the results look like. Positive, negative, totally inconclusive, doesn't matter. This simple change completely removes the pressure to find a good story. It rewards good science, not just exciting results. All of these solutions are part of a bigger movement. It's a real cultural shift toward building a scientific community that's tougher, more honest, and more deserving of our trust. Look, it's not going to be one single magic bullet that fixes everything. It's a whole bunch of things working together. You've got pre-registration to lock in the plan, open data and code so everyone can see what you did, a new focus on good methods instead of just results, better education in statistics, and, maybe most importantly, changing the very incentives that drive researchers to act this way in the first place. And really, that gets to the heart of it. Yeah, p-hacking is about misusing statistics, but the root of the problem goes so much deeper. It's a human problem. It's fueled by a publish or perish system that puts insane pressure on researchers to churn out exciting results no matter what. So the fix isn't just about better math. It's about building a better, more honest system for everyone. So I want to leave you with this question. Next time you're scrolling and see a headline about some amazing new scientific discovery, what are you going to check for? Being a smart consumer of science today means asking the tough questions. Was this study pre-registered? Can I see the data? A little healthy skepticism isn't about distrusting science, it's about demanding the very best version of it.